Good morning, students. We have studied about the lateral earth pressure for at rest condition. Okay. So next we have to study about the lateral earth pressure for active and passive condition. So before that, we can discuss about two theories. That is based on this theory, they have developed active and passive earth pressure. Okay. So the theories are Coulomb's earth pressure theory and Rankine's earth pressure theory. So first one, Rankine's theory of earth pressure. So for developing this earth pressure theory, Rankine assumed these factors. So first one, the soil mass is semi-infinite, homogeneous, dry and motionless. Okay. Second one, the soil is in a state of plastic equilibrium during active and passive earth pressure conditions. So during these conditions, the soil is in a state of plastic equilibrium and the failure surface is a planar surface, and it is obtained by considering this plastic equilibrium condition of the soil. Okay. Then about the the backfill surface is horizontal and the back of the wall is vertical and smooth. Okay, so these are the assumptions, and based on these assumptions, Rankine has developed earth pressure theories. So before going to this theory, we can briefly discuss what is meant by active and passive Rankine state. That is, in the case of active condition, the soil mass stretches. That is, the soil mass will get expanded because the retaining wall is moving away from the soil mass. So it will get expand and the lateral earth pressure will decreases. Okay. And in passive condition, the soil mass get compressed because the retaining wall is moving towards the backfill soil. So it is get compressed and the lateral earth pressure will get increased. Okay. So this is active and passive condition. So in active case, the retaining wall is moving away from the backfill soil and the lateral earth pressure will get reduced. Okay. And in the case of passive condition, the retaining wall is moving towards the soil mass. So its lateral pressure will get increased. Next, for an element of soil which is at a depth set, what is the value of vertical stress? Vertical stress is equal to unit weight of that soil into that depth set. Okay. So what is horizontal stress? If we know the earth pressure coefficient K, if it is an active if it is an active condition, that constant will be Ka. Okay. So here we are discussing about active condition. So the horizontal stress will be equal to coefficient of earth pressure for active condition into this vertical stress, because what is this coefficient of earth pressure is equal to sigma h by sigma v, that is horizontal stress by vertical stress. So horizontal stress is equal to this constant K into vertical stress. Okay. So horizontal stress or lateral earth pressure is K into vertical stress, K into gamma into Z. Okay, so these are the basic things we have studied about this in at rest condition. Okay. So next we can discuss about active and passive condition. So for that there is a Mohs circle. So you have studied Mohs circle in your MOS. So I hope you all know about this. Here you should not draw this Mohs circle, just see the variation. Okay. So here you can see it is active pressure condition and it is the at rest pressure. Okay. Then it is the passive pressure. In x-axis, the pressure is marked on x-axis. Yeah. So in the case of active earth pressure, I have said that the retaining wall is moving away from the backfill soil. So its earth pressure will get decreased. Okay, so it is the origin for active condition, and since the earth pressure is getting reduced, it is moving like this. Okay, and finally the when the earth pressure is getting reduced and failure will occur, that is, if we are drawing this Mohs circle, the earth pressure is getting, or the pressure is getting reduced and it will touch the failure envelope. So at that point failure will occur. Okay, this failure envelope you have studied in your shear strength chapter in. So so when the Mohs circle touches the failure envelope, the soil will fail. Okay, so this is the condition of active earth pressure. Since in active earth pressure the lateral earth pressure is decreasing, we are drawing Mohs circle like this. That is, it is moving direction is in this way, and it touches the failure envelope. and when it touches the failure envelope, failure of the soil occurs, and that point is the active earth pressure. So this is the active earth pressure. And in the case of passive earth pressure, this is the origin. So in the case of passive earth pressure, the retaining wall is moving towards the backfill soil, so earth pressure is getting increased. So it increases like this, and it increases and it touches the failure envelopes. When this Mohs circle touches the failure envelope, soil will fail. Okay, so at that point we have to note the passive earth pressure. Okay, at that point we are drawing the Mohs circle for minor by considering the minor stress value and major stress value, and this is the passive pressure. Okay, so this is the variation. From the geometry of these Mohs circles, it is very clear that for active case, Ka is equal to 1 minus sin phi by 1 plus sin phi. This derivation and all is not required. You just study this equation only. That is Ka is equal to, that is coefficient of active earth pressure Ka, and this Ka is equal to sigma h by sigma v. It's for all cases. It is horizontal stress by vertical stress is K, and Ka is equal to 1 minus sin phi by 1 plus sin phi. Okay, and it can be also written like that, tan square 45 minus 5 by 2 in the case of active earth pressure. And for passive case, Kp, it is not as Kp. Kp is equal to 1 plus sin phi by 1 minus sin phi, just reverse of this value. Okay, so it can be written as tan square 45 plus 5 by 2. Okay, so you should be thorough about this equation. What is the expression for Ka and Kp? Ka is equal to 1 minus sin phi by 1 plus sin phi, and Kp is equal to 1 plus sin phi by 1 minus sin phi. Okay, so you can by heart this value by remembering one thing, that is, in the case of Ka, for active case, earth pressure is decreasing. Okay, since it is decreasing, for numerator it is minus 1 minus sin phi by 1 plus sin phi. So remember that thing. And likewise in the case of passive, earth pressure is increasing. So for numerator it is plus 1 plus sin phi by 1 minus sin phi. So like this you can by heart this equation for Ka and Kp. So in terms of tan square, for active it is minus, and for passive it is plus, because for active it is decreasing and for passive the earth pressure increasing. So like that you remember this equation. Next, for the orientation of failure plane, and the orientation of failure plane is just reverse. That is, in the case of active it is 45 plus 5 by 2, that is orientation of failure plane with the horizontal. Okay, for active case the inclination of this failure plane is 45 plus 5 by 2. In the case of passive it is 45 minus 5 by 2. That is, here we are for active we are for finding or for calculating Ka, we are taking only minus 1. Okay, that is 1 minus sin phi here tan square 45 minus 5 by 2. And for passive we are always first writing this plus value. But in the case of failure, inclination of this failure plane, it is just reverse. That is, for active it is 45 plus 5 by 2, and for passive it is 45 minus 5 by 2. Okay. And these all things we are deriving from this Mohs circle, but derivation is not required. So just by heart this equation. Okay. Then first we can consider first case, that is active earth pressure of cohesionless soil. So for that, consider a cohesionless soil of unit weight gamma, and it is the height of retaining wall, that is capital H, and we are considering the soil mass at a depth Z. So for that depth, what will be the earth pressure? If it is active, it is Ka into gamma Z. Here it is K naught, but it is Ka into gamma Z. For active, we are noting as Ka into gamma Z, that is the active earth pressure. And at the bottom, since the total height is H, it is Ka into gamma into H. And the total lateral earth pressure force is acting at a height of H by 3. And for calculating this Pa, we are taking the area of this triangle. So that is half into Ka gamma h into h, that is half Ka gamma h square. This is same as that you have studied in your at rest condition. The only difference is there it is K naught, here it is Ka. Just changing that constant only. Okay. So this is the first case, that is for portionless soil without water table and without any surcharge. So at a depth z below the surface, sigma v vertical stress is equal to gamma into z, and assuming that wall yields sufficiently for active condition to develop, the sigma h is equal to Ka into sigma v. Okay, that is Ka into sigma v is equal to unit weight of soil into z, Ka into gamma z. So this sigma h horizontal stress is equal to Ka into gamma z, where Ka, that is for active case, what is Ka is 1 minus sin phi by 1 plus sin phi, or tan square 45 minus 5 by 2. Okay, phi is the angular shear resistance. Then for this is for height z, and for total height of h of the wall, the total thrust Pa on the wall per unit length of the wall, which is acting at a height h by 3 from bottom. Okay, it is given by or it is calculating or it is determining by taking that area of the triangle, that is Pa is equal to half Ka into gamma h square, and this may be taken to act at a height of h by 3 above the base through the centroid of the pressure distribution diagram. So this is about the active earth pressure. And next case, in the case of active earth pressure, if there is any submergence, that is if the water table is at the ground level, the soil will be in submerged condition. So at that case, as I have explained in at rest condition, we have to consider two things, that is lateral earth pressure due to submerged unit weight of this backfill soil and lateral pressure due to pore water. We have to consider the pressure due to water. Okay. So here two parameter will come, that is at a depth h, capital H, this is the total height of the retaining wall. So at a depth h below the surface, the lateral earth pressure sigma h is given by first one, the earth pressure due to this backfill soil which is in submerged condition. So we have to take gamma dash, that is Ka into gamma dash into h, because the soil is in submerged condition. So we have to take submerged unit weight, plus we have to take the pressure due to pore water. So unit weight of water into h. This is same as in your at rest condition. Only change is that here it is Ka and it was K naught, Ko. Okay. So these are same. And I have told that in the case of when we are taking lateral pressure due to pore water, you should not multiply with Ka, because this Ka is the parameter for soil only by considering phi. This Ka is equal to 1 minus sin phi by 1 plus sin phi. It's a physical parameter of the soil. So by when we are taking the lateral earth pressure due to pore water, you should not multiply it with Ka. Then next case is effect of partial submersion, that is what here it is water table. So above this water table, the soil will be in dry condition, and below it will be in submerged condition. A lateral earth pressure above water table is due to moist unit weight of the soil, that is bulk unit weight of the soil, and that below the water table is the sum that due to the submerged unit weight of the soil and that of the water. Okay, that is below we have to consider the water pressure due to submerged unit weight of soil and that due to water pressure. So that what will be the value? Here it is Ka into gamma bulk unit weight into H2. Okay, and here this will be this earth pressure due to this height H1 will be constant for this one. So you produce it as the rectangle because it is constant, because it is not depending this height H1, it is only depending on the height H2. So you reproduce this in the bottom, that is Ka into gamma into this height H2. Then next you consider the earth pressure due to this backfill soil for a height of H1, that is Ka into gamma dash into H1. Here we have to take gamma dash because here it is water table, so the soil is in submerged condition, plus the earth pressure due to pore water, that is unit weight of water into height H1. Okay, so lateral earth pressure at the base of the wall, Ka into gamma H2. It is due to the bulk unit weight of the soil for a height H2. then below K into gamma dash H1 plus pressure due to water, that is unit meter water into height H1. Okay. Then H1 depth of submerged fill and H2 depth of fill above the water table. Then gamma dash submerged unit weight and gamma is the moisture unit weight. So this is the equation if the water table is in between. The next case is effect of uniform surcharge. Okay, so if there is any surcharge weight which is noted by Q acting on the surface of the retaining wall, we have to consider its value as a uniform value. So this is Ka into that surcharge weight Q, and it will be same at all the points, so it will be in rectangle variation. Next we have to consider the earth pressure due to this soil, so that is Ka into gamma into Z, and if there is any water table, this will become gamma dash, that is the difference. And also we have to add earth pressure due to water also. Okay, so the what is meant by surcharge? The extra loading carried by a retaining structure is known as surcharge. It may be uniform load or line load or isolated load. So in the case of wall retaining a backfill with horizontal surface level with top of the wall and carrying a uniform surcharge of intensity Q per unit area, the vertical stress at every elevation in the backfill is considered to increase by Q. That is, at every elevation it is same. Okay. So as such, the lateral pressure has to increase by, so this lateral pressure increases by Ka into Q. Since here we are considering the lateral pressure, we have to multiply with this Q, that is the increase in stress by this Ka. So it becomes Ka into Q, and it is same at every point irrespective of the height or depth. So Ka into Q. So at any depth set, sigma h is equal to K into gamma into Z. This is the earth pressure due to the backfill soil plus this pressure due to surcharge weight, that is Ka into Q. Okay. So these are the different cases of active earth pressure. So first we have discussed about the active pressure for the simple case, that is there is no water table and there is no surcharge weight. Next we have considered if there is any submergence, that is if there is any water table, we have to take the submerged unit weight, and also we have to add the lateral pressure due to pour water. And if there is any surcharge weight, it has to increase by Ka into Q at every elevation. Okay. So thank you.